Have you ever looked up at the night sky and felt a sense of wonder? The vast expanse above us, dotted with countless stars, has always been a source of fascination and curiosity for humanity. Thousands of stars twinkle above us, a breathtaking sight that has inspired poets, scientists, and dreamers alike. Each star, a distant beacon of light, tells a story of the universe's past. Each one is a distant sun, perhaps with planets of its own, orbiting in a delicate cosmic dance. These stars, though seemingly close, are separated by vast distances, each a world unto itself. But did you know that we are looking at only a tiny fraction of the stars in our galaxy? The Milky Way, our galactic home, contains billions of stars, many of which are hidden from our view by cosmic dust and gas. Our galaxy, the Milky Way, is a vast city of stars, a sprawling metropolis in the cosmos. It is a place of incredible diversity, with stars of all ages and sizes, from young hot blue stars to ancient cool red giants. It stretches for hundreds of thousands of light years, a colossal structure that defies our everyday understanding of distance. To put it in perspective, light, traveling at an incredible speed, takes over 100,000 years to cross from one side of the Milky Way to the other. We live on a small planet orbiting an average star somewhere in the Milky Way's suburbs. Our solar system is just one of many, nestled in a quiet corner of this grand galactic city. But how did this enormous structure come to be? The formation of the Milky Way is a tale of cosmic evolution, shaped by the forces of gravity, dark matter, and the remnants of ancient stars. How did the Milky Way form, and what is its ultimate fate? These questions drive astronomers to peer deeper into the universe, seeking answers in the light of distant stars and the faint glow of ancient galaxies. These are some of the most fundamental questions in astronomy. By studying the Milky Way, we not only learn about our own galaxy, but also gain insights into the nature of galaxies throughout the universe. By studying the Milky Way, we learn about our place in the universe. We uncover the history of our cosmic home and gain clues about the processes that shape galaxies throughout the cosmos. We uncover the history of our cosmic home and gain clues about the processes that shape galaxies throughout the cosmos. The Milky Way is a living laboratory, offering a window into the past and a glimpse of the future. Join me on a journey through time and space as we explore the mysteries of the Milky Way, from its explosive origins to its uncertain future. Together we will unravel the secrets of our galaxy and discover what it can teach us about the universe at large. To understand the Milky Way's birth, we must journey back to the very beginning, the Big Bang. This monumental event marks the origin of everything we know, from the smallest particles to the vast galaxies that populate the cosmos. Imagine a universe compressed into a single point, unimaginably hot and dense. This singularity held all the energy and matter that would eventually form the universe. Then, about 13.8 billion years ago, this point expanded in a colossal explosion, the Big Bang. This explosion wasn't just an explosion of matter, but of space itself, creating the dimensions we live in today. In the first moments after the Big Bang, the universe was a chaotic soup of energy and particles. Temperatures were so high that particles couldn't form stable atoms, leading to a turbulent cosmic environment. As the universe expanded, it cooled, and the first atoms began to form. This cooling allowed particles to combine and create the building blocks of matter. These were primarily hydrogen and helium, the simplest and most abundant elements in the universe. These elements would later play a crucial role in the formation of stars and galaxies. This early universe was not yet structured. It was a vast expanse of gas, mostly hydrogen and helium, with subtle variations in density. It was a vast expanse of gas, mostly hydrogen and helium, with subtle variations in density. These variations were the seeds of future cosmic structures. These density fluctuations, tiny ripples in the fabric of space-time, would eventually lead to the formation of galaxies like our Milky Way. Over millions of years, gravity would pull these denser regions together, forming stars and galaxies. From this simple beginning, the stage was set for the emergence of stars, galaxies, and ultimately, life itself. The universe, once a chaotic and unstructured expanse, began to take on the complex and beautiful forms we observe today. Over millions of years, gravity began to sculpt the early universe. Regions of slightly higher density attracted more matter, pulling in surrounding gas. These dense regions became the seeds of galaxies. Within these swirling clouds of gas, smaller clumps collapsed under their gravity. As the gas contracted, it heated up, eventually reaching temperatures high enough to ignite nuclear fusion. The first stars were born. These early stars were very different from our Sun. They were much more massive and short-lived, burning brightly for a few million years before exploding as supernovae. These explosions enriched the surrounding gas with heavier elements, the building blocks of planets and life. Over time, countless stars formed within these proto-galaxies. They clustered together, drawn by their mutual gravity. These clusters of stars merged and interacted, their gravity pulling them into larger and larger structures. The Milky Way, like all large galaxies, grew through a series of mergers and collisions with smaller galaxies. Over billions of years, these interactions have shaped the structure and composition of our galaxy, making it the magnificent spiral we see today. Imagine a cosmic dance with galaxies swirling around each other, drawn together by their mutual gravitational pull. This gravitational ballet is a slow and intricate process where galaxies gracefully approach, interact, and eventually merge. These galactic collisions are not head-on crashes, but rather drawn-out mergers that can last for billions of years. During this time, the galaxy's stars, gas and dark matter gradually combine, creating new structures and triggering various cosmic phenomena. As galaxies approach each other, their gravity distorts their shapes, pulling out long streams of stars and gas. These tidal tales are a testament to the powerful gravitational forces at play, stretching and warping the galaxies in a dramatic display. These mergers are essential for galaxy evolution. They not only change the physical appearance of galaxies, but also influence their internal dynamics, star formation rates, and overall growth. They trigger bursts of star formation as gas clouds collide and collapse. When galaxies merge, their gas clouds are compressed, leading to the birth of new stars in a spectacular burst of activity. They also funnel gas toward the galactic center, fueling the growth of supermassive black holes. This influx of gas can ignite active galactic nuclei, making the centers of merging galaxies some of the brightest objects in the universe. The Milky Way continues to experience these galactic encounters. Even now, our galaxy is interacting with several smaller satellite galaxies, gradually pulling them in and incorporating their stars and gas. Astronomers have found evidence of past mergers in the motions of stars within our galaxy. By studying the orbits and velocities of stars, they can trace back the history of these ancient collisions and understand how they have shaped the Milky Way. And we are currently on a collision course with our nearest large neighbor, the Andromeda Galaxy. In about 4.5 billion years, the Milky Way and Andromeda will merge, creating a new galaxy. This future collision will be a grand event, reshaping the night sky and the structure of our cosmic home. The Milky Way is a barred spiral galaxy with its hundreds of billions of stars arranged in a flat disk with spiral arms. At its center lies a supermassive black hole, a region of extreme density with a gravitational pull so strong that not even light can escape. Surrounding the central bulge is a flat disk of stars, gas, and dust. This disk is where most of the Milky Way star formation occurs. The spiral arms are regions of higher density within the disk, where gas clouds are compressed, triggering the birth of new stars. Our Sun resides in one of these spiral arms, about 26,000 light-years from the galactic center. We orbit the Milky Way's center at a speed of about 500,000 miles per hour, taking roughly 230 million years to complete one rotation.